Today we're going to be looking at integration in mechanics. This is just for the Year 12 course, the A-level course. So what we looked at in the last couple of videos is that we can use differentiation to go between displacement, velocity and acceleration. Well, if we can use differentiation to go from displacement to velocity and then from velocity to acceleration, then surely we can then integrate the other way. So if we integrate acceleration with respect to time, we're going to get velocity, and if we integrate velocity with respect to time, we're going to get displacement. And that's exactly what we're going to be doing in today's video. So here's a nice simple example to start with. This is a velocity time graph. I'm given the equation of the graph. I'm told that v is equal to 8 plus 2.5t, and I can see that it is a linear graph, which means the gradient is constant. So if I were to differentiate with respect to time, I would get dv by dt, which is a, which comes out to be 2.5. So with this question, which I'll ask a question in a minute, with this question, we have acceleration is constant, which means the Suvat equations will work. Okay, so I'm going to solve this in two different ways. Number one, I'm going to use calculus, and then number two, I'm going to use Suvat. Okay, so v equals 8 plus 2.5t. Well, that means it's going to be crossing the v-axis at 8. That's its initial velocity, and then after 6 seconds, it's going to be 15 meters per second faster. So 15 plus 8 is, well, it's going to be 23. Okay, it's t is 6. And the question is, well, what distance or displacement has this object travelled in the first 6 seconds of motion according to this model? Well, the displacement of the first 6 seconds, which I'm going to call s, is going to be equal to the integral between 0 and 6 of v, which is 8 plus 2.5 t dt. Evaluate that. That's going to be 8t plus 1.25 t squared between 0 and 6. Okay, so I come out the integration. And then I can substitute in my values. So that's going to be 8 times 6, which is 48. Plus 6 squared is 36, times 1.25 is 45. Plug in the 0, that's going to be 0 in both cases. So that's going to equal 93 meters. So by using calculus, I get the answer of 93 meters. Let's just confirm this is the same answer that Suvat will give us. So S, U, V, A, and T. S is my unknown, so I'm going to call that x. U is my initial velocity, which according to my graph is 8. V is my final velocity, which is 23, and T is 6. 8, 23. I know that A is 2.5 and T is 6. I know that A is 2.5 because I differentiated velocity a minute ago. And that's why I can use Suvat, because the acceleration is constant. And then I can just choose that Suvat equation. I've got 4 of the values, so any will do. I'm going to use S equals ut plus a half at squared. So that's going to be 8 times 6 plus a half times 2.5 times 6 squared. 8 times 6 is 48. And then a half times 2.5 is 1.25 times the 6 squared gives me the 45. In fact, those are the same two values I got a minute ago. And that's equal to 93 meters. Okay. And the reason why it works in this case is because if S is indeed ut plus half at squared, and if I do differentiate that with respect to time, I will get v is equal to u plus at. And that is obviously only true if the acceleration is constant. If the acceleration is a function of time, then that term there wouldn't differentiate to this. It's only that the fact that a is constant that this works. Okay, and we managed to get out then that, well, differentiate again, d by dt. We'll get that a is equal to a. Obviously, acceleration is acceleration. Okay, so it works in this case only because the acceleration is constant. It will not work in my next example because in my next example the acceleration is not constant. So here I've got a particle. It's travelling in a straight line, and it'll always travel in straight lines for year 12. After t seconds, its velocity v meters per second is given by v is equal to 15 plus 2t minus t squared for t values greater than or equal to 0. Find the distance travelled in A, the first 3 seconds of motion, and B, the second 3 seconds of motion. Okay, so let's tackle part A first. What I'm going to do is I'm going to have a go at sketching this graph. So this is not a pure course, so I'm not going to go through how we're going to sketch it. If you want to find that out, then have a look at some pure videos. But it's got roots at -3 and 5. That's my t-axis, and my v-axis is here, and it crosses there at 15. It's a negative quadratic, so it's going to do that. So my first question, part A, is to essentially calculate this area here. That's what it's asking. It's asking me for this area up until 3 seconds. So what I'm going to do is I'm going to integrate v with respect to time between t values of 0 and 3. So my answer to part A is I'm going to call it x1 is going to be equal to the integral between t values of 0 and 3, because it's the first 3 seconds of motion, v, which is 15 plus 2t minus t squared with respect to t. And because this isn't a linear graph, the acceleration is not constant, so suvat will not work. And we can see from the graph it's not a linear graph. The acceleration is not linear. And if you differentiate this, you're going to get a function of time, not constant. So therefore, we cannot use suvat. So that's going to equal 15t plus t squared minus a third t cubed between t values of 0 and 3. And then plug in my upper limit. My lower limit will give me 0, so that's not a problem. So I get 45 plus 9 minus 27 divided by 3, which is 9. So that's going to equal 45 meters. So it travels 45 meters in the first 3 seconds. For part B, I need to be a little bit careful, because the question has asked for the distance travelled in the second 3 seconds of motion. And the issue with that is in the second 3 seconds of motion, the velocity goes to 0 and then becomes negative. So I'm going to draw the sketch again. I'm now looking to my second 3 seconds. That's between seconds 3 and 6. There's my time axis, there's my velocity axis, and it's got a root there at 5. Now the distance is equal to the area here and here. Displacement is a different question. Displacement would be the area here minus the area here, because the area here is below the t-axis, so it's moving in the negative direction, whereas here it's moving in the positive direction, because it's above the t-axis. But it's not asked for displacement, it's asked for distance. So we want the absolute area. So the only way to get this, which I'm going to call x2, is going to be the integral between 3 and 5 of my function of t. That's v with respect to t. And then I need to subtract the integral from 5 to 6 of this function of t, because I know that's going to come out to be negative. Okay, that's going to be a negative number, this integral, so I want to take it away, so then I'm actually adding the area. Okay, so you've got to be really careful with questions regarding distance. So if I know the integral, I can actually use a calculator for this. You're allowed calculators in the exam, so it's not a problem. So here's my calculator. I'm going to evaluate this integral here. So I'm going to integrate 15 plus 2t, calculated as x, minus t squared between t values of 3 and 5. And then I'm going to subtract the integral of 15 plus 2t minus t squared between t values of 5 and 6. And that will do both integrals at once. I would recommend writing out the two values of the two integrals separately, just so the examiner can see that you've done the correct working. just in case you do something wrong. Or it might be worth even popping in the actual integral function. So writing something like 15t plus t squared minus a third t cubed between 3 and 5, and then subtract 15t plus t squared minus a third t cubed between 5 and 6. Just so the examiner can see that you know how to evaluate these. But then you can use a calculator to give you the final answer. Leave it as 53 thirds. You can still get the marks if you write it as 17.7 or 17.6 recurring, but a fraction is generally better. Thanks for watching.